Hello and welcome to our project video demonstration for Dell EMC Envision the Future competition. In this video, we're going to demonstrate the functionality of our sign language real-time interpretation system. But before we dive in, we'd like to give a brief background on the topic of sign language recognition. Sign language recognition could potentially change the lives of deaf-mute people, as it will break the communication barrier and allow them to communicate with those who are not familiar with sign language. There are two main challenges in creating a sign language recognition system. The first is capturing the sign language gestures from the signer, which implies continuous tracking of the signer's hand position and posture. The second challenge is recognizing and then converting the symbolic meaning of the sign gesture to the corresponding written or oral form of the language. Sensor gloves, RGB cameras, and computer vision algorithms and pipelines were previously utilized by researchers to tackle the challenge of capturing and tracking the user's hand. And while these technologies have their strengths and could accomplish the task with high accuracy, they each come with their own drawbacks and limitations that keep them from seeing commercial success in the market. Sensor gloves, for example, can accurately capture the gestures or finger spellings of their users. But they, however, come with a hefty price tag, and most people in the deaf-mute community find them cumbersome and awkward to use in public. On the other hand, RGB cameras, or depth sensing cameras, such as the Microsoft Kinect sensor, make the process of capturing and tracking the user's hands very easy. But as with the case of the sensor gloves, they too require the purchase of expensive specialized hardware equipment. That is, the depth sensor itself. Not to mention that such devices require powerful graphical processing units to process the large amounts of visual data generated by the depth sensor. Before we began the process of implementing our sign language recognition system, we highlighted the qualities and characteristics that we desired our software solution. First, we wanted our software solution to be accessible more than anything else. This means that our solution should not require the user to buy any special hardware and should instead be implemented to work with ubiquitous or common hardware. Second, our software solution needs to have a high degree of accuracy when predicting the symbolic meaning of the signaled gestures. Third, we want our software solution to work in real time, which means that latency should be minimized as much as possible. Fourth, it needs to work regardless of the background environment where it is being used. This means that the user could be sitting at their home where the background is more likely to be static, or in a busy coffee shop where the environment is expected to be erratic and continuously changing, and the software solution should work as expected. Finally, our software solution needs to be easy to use and intuitive. It should require little time from the user to get up and running with the program. Our software solution deploys two deep neural networks to tackle the main challenges of creating a sign language recognition system. The state-of-the-art YOLO v3 object detection deep neural network is used for detecting and tracking the user's hand position, while Google's MobileNet v1 deep neural network is used for gesture recognition. Both neural networks have achieved a high degree of accuracy after being trained on large data sets that were generated using creative data augmentation and automated image annotation techniques that involve the usage of a green screen or chroma and a computer vision pipelines that were built by our team. Continual learning is implemented on the recognition deep neural network to make it automatically increase its accuracy over time as it's being used. Here is a video demonstration of a colleague using our first iteration software system running on top of Microsoft Windows. The user blinks to signal to the system to register a sign gesture. To ensure that the system doesn't pick non-voluntary blinking as register signals, the user needs to blink for more than 4 frames before the blinking is registered. The user can change the blinking threshold using this track bar in the settings panel to his desired speed. If both hands are detected on the screen and a blink register is signaled, then the system will always give the control hand priority and register its sign gesture. The following control gesture is used to convert the inputted text to synthesized speech. You will not be hearing the synthesized speech, unfortunately, because we decided to not record the sound of this demo video to conceal our identity. Thank you for watching. To learn more about the implementation details of our software solution, please read the final report that will be submitted along this video.